So the purpose of this video is to review some key concepts about stoichiometry so that we can use them and be very strong in our abilities to do more complicated stoichiometry problems in the future. So let's break down this word stoichiometry first. Metry means measure, and stoic comes from the word stoichion, which means elements. So the word stoichiometry itself is just how it means measuring elements. It's quantitative, involving numbers, measurements of compounds, including their mass, the number of atoms, the number of molecules, etc. Okay. Now, we always think of chemistry in terms of atoms. So whenever we're talking about matter, we should just talk about the number of atoms present. Well, the problem is, it doesn't make any sense to count atoms, because atoms are so small. We need to use a different quantity, a different term, to represent a large number of atoms. And that term that chemists have decided on is called the mole. Now, it's not this guy over here, okay? We're talking about 1 mole. And what does 1 mole represent? 1 mole is just a word that represents a number. And that number is 6.02 times 10 to the 23rd. This is otherwise known as Avogadro's number. Okay. 1 mole of anything represents 6.02 times 10 to the 23rd of anything. That is a definition that we need to know, the definition of a mole. 1 mole of anything represents 6.02 times 10 to the 23rd of that thing. So, 1 mole of pencils represents 6.02 times 10 to the 23rd pencils. And remember, this is an extremely large number because the exponent is times 10 to the 23rd. An analogy to remember the term mole is just think about 1 dozen. The word dozen, we know, means 12 things, whatever those things are. So for example, we could talk about a dozen roses. If we had a dozen roses, that means we have 12 roses. If we said we have a dozen donuts, we have 12 donuts. A dozen eggs means 12 eggs. We could also just use the word mole instead, but instead of representing the number 12, we're now talking about this many, Avogadro's number of that thing. So how can we use that to do conversions? Well, an example down here. How many atoms are in 2 moles of carbon? Well, if we have 2 moles of carbon, we know that in every 1 mole, there are 6.02 times 10 to the 23rd atoms. And if we're remembering our dimensional analysis, whatever units we have in the numerator up here need to be the same in the denominator so they cancel out. So 2 moles, well, we know for every 1 mole, we're going to have 6.02 times 10 to the 23rd atoms. So if we were setting this up, it may seem very simple right now, but the underlying skill is super important for more complicated problems. If we do the math, we'll be left with 2 times 6, which gives me 12.04 times 10 to the 23rd. But now we want to make sure we can write that in scientific notation. And to do that, we move the decimal over. This becomes 24th. So the final answer would be 1.2 times 10 to the 24th atoms of carbon. We can go the other way, the same way, but instead of talking about atoms, we can talk about molecules. Remember, a molecule is something that has more than, greater than, or equal to 2 atoms present. So for example, how many molecules are in 3 moles of CO2? The reason I have to use the word molecules is because carbon dioxide has 3 atoms. It has 1 carbon and 2 oxygens. Whereas up here we were just talking about 1 element, carbon. So it's the same idea. 3 moles. I want to know how many molecules that's going to be. I'm going to need to use the same relationship from Avogadro's number. 1 mole is equal to 6.02 times 10 to the 23rd, in this case, molecules. And if you do the work and you check your answer, you should get 1.8 times 10 to the 24 molecules. That's using Avogadro's number. But the problem is we don't usually measure things in the lab using atoms and moles. We have to use more practical things. We have to use mass. We use scales. So this is where the role of molar mass comes into play. So another definition we need to know. Molar mass. The molar mass is the mass of 1 mole of a substance. Whatever that substance is. It can be 1 atom. It can be 1 element, I should say. It could be a compound, whatever. So for example, if we look at the periodic table here, just to refresh our memory, this should be pretty review. For nitrogen, we have this mass right here of 14.007. This means that 1 mole of nitrogen, pure element N, equals 14, and I'm just going to round it, grams. What if I had O2? Well, now I have 2 atoms of oxygen, so if each one, we'll just round this to 16. 16 times 2, the total molar mass of O2 is going to be 32. And the units when we're representing molar mass are grams per mole. Remember, we can rewrite this just as 32 grams per 1 mole. All I'm doing is taking that divided symbol and flipping it on its side. And the reason we want to do that is for stoichiometry purposes. So for example, how many grams are in 3 moles of N2? Well, my given is 3 moles of N2. I need to convert that in this case to grams. So I'm not going to need Avogadro's number, I'm going to need molar mass, because grams are the units for mass. I know in 1 mole of N2, what is its mass going to be? Well, I got to check the periodic table. Nitrogen, we said, has a molar mass of 14. But we have 2 atoms of nitrogen here. So 2 times 14 is going to give me a mass of 28 grams. So if I do the math here, my moles cancel. 3 times 28 is going to give me a final answer of 84 grams of N2. And if I'm being a stickler, we got to watch our sig figs. So 3 is the only given in the problem. That has 1 sig fig. So my final answer needs to have 1 sig fig. Right now it has 2. So it really should be 80 grams of N2. What about going the other direction? How many moles are in 40 grams of magnesium hydroxide? Oh, there's no formula written. You got to use your nomenclature. Well, magnesium, I know, is Mg, and it has a +2 charge. Hydroxide, I need to have memorized, is OH minus 1. So if I use my crisscross method to write the formula, I'm going to know the formula for magnesium hydroxide is going to be Mg, 1, from the -1 here, OH, 2, to balance it out. So now let's do the problem. Okay, my given is 40 grams of Mg, OH2. I want to figure out the number of moles. So I need to figure out the molar mass of magnesium hydroxide. So go ahead and check your periodic table to figure that out. And if I do a little bit of rounding, magnesium has a mass of 24. OH is 17, and I have 2 of them. So 17 times 2 would give me 34, plus 24 would give me 58 grams per 1 mole. So if I did the math here, I'm going to be left with 40 divided by 58, which, if you check yourself on a calculator, is going to give you 0.69 moles. Again, if we were watching sig figs, 40 grams is the only given. It has 1 sig fig, so my final answer should be 0.7 moles. 1 sig fig. That just has 1 sig fig. Let's move on to some more complicated grams to grams conversions now.